Hello all. As a continuation of my lecture series in special electrical machines, uh, we are learning the topic theory of torque prediction. So in the previous video, we have discussed about the mechanism of static torque production in variable reluctance motor and the case of infinitely permeable cores and the another case of constant permeability. So this derivation is for constant permeability. So let us consider the case of constant permeability where the infinite permeable cores, the magnetic field appears only in the gaps and its magnetic treatment is simple. When cores are of finite permeability, on the other hand, magnetic energy appears not only in the air gaps but also in the cores and spaces other than the gaps. If the coil inductance is L, in the model of figure, the flux linkage phi is given by phi is equal to L into I. So here we are considering it as constant permeability. So there will not be any nu naught values. The magnetic energy in the system is expressed as Wm is equal to half into Li square, which is stored energy. If the iron piece undergoes displacement del x during the time interval del t, and the inductance will increase by del L. So E is equal to, we all know that, minus del phi by del T. So instead of flux linkage, we can substitute L into I. So the equation becomes minus del Li by del T. If the power supply is a current source and provides a current I during displacement, then it becomes E is equal to minus I into del L by del T, which makes equation 4. And coming to work done, del Pi is equal to I into E into del T, where we can substitute equation 4 here, and I into del L by del T into del T. So where del T and del T gets cancelled and the equation becomes I square del L, which makes equation 5. So on the other hand, the increase in the magnetic energy del omega m is equal to half into I square del L. So from comparing the equations 5 and 6, it is seen that the half of the work done on the circuit by the source is converted into mechanical energy. So hence it is supposed that the other half is converted to mechanical work. So the mechanical work is del P naught is equal to F into del X, which is equal to half into I square del L. So then the force F is equal to half I square del L by del X. So this gives the equation for 4. So in this equation, this is very simple compared to infinite permeability, where we will be having many parameters like magnetic field intensity, mu naught and air gaps. But here we are directly substituting the flux linkage value, and that flux linkage value is directly substituted to EMF equation, in which in turn it is converted to magnetic energy, and finally we have derived the force equation. So we will have some assignments. So in a stepper motor, detent torque means maximum of the static torque with phase winding unexcited, minimum of the static torque with phase winding unexcited, minimum of static torque with phase winding excited, and maximum of static torque with phase winding excited. So this is either it may be maximum or minimum and excited or unexcited condition. So detent torque is maximum of the static torque with phase winding unexcited. Coming to the next question, which of the following motors can have the highest operating speed? So the stepper motor or capacitor start motor or brushless DC motor or universal motor. So brushless DC motor is the highest operating speed among the list of motors. So in this video we have clearly discussed about the torque prediction and case of infinite permeability and case of constant permeability and its assumptions. So in the upcoming videos, we will be clearly seeing about the microprocessor based control and drive circuits, and along with linear analysis. So we have another linear analysis to derive the torque equation. So we will see in the upcoming videos. Thank you. So the case of constant permeability. So permeable course and constant permeability and along with the equations.